Hello.
Good morning, ma'am.
Good morning. Good morning, all. So we'll start the lecture. Actually, sir is on leave today, HOD sir. So I will conduct the lecture from 10:30 to 11:30, and afterwards you have the practical at 12:10. Okay. So I think I have given one task in the previous lecture to write a program that is the square wave at P1.0, and the timer selection is mode 2 and timer 1. So have you tried anyone? Have you tried? I have given the logic also ki, what should be the flow of the program as it is a timer 1 and mode 2. What is the size of timer in mode 2? So that we have discussed in the previous lecture, and the value to be loaded is just 5. Pi value, or what should be the value range of the value to be loaded in the timer register? 0 to FF. Why? Because its timer is 8-bit timer in mode 2. So anyone has tried the program, anyone has written the program or tried the logic, or can orally can you tell the steps or what will be the change, because the basic structure remains same. Already in the day one I told ki for timer programming the basic structure, basics frame of the program remains same. That is the statement. Somewhat changes according to the mode and according to the calculations. So these steps you have to remember. First of all, load the T mod register, then load the timer register. Then if any port you are requiring, just complement or pass the value to that port. Then start the timer, just pull the timer overflow flag, and then clear the timer, means stop the timer, clear the TF0 flag, and that's it. This is a basic structure, this is a basic flow for any timer programming, but according to the statement user has to make some changes according to the problem statement. So anyone? Hello? I have tried, madam. I have written this code. Just check it whether it is correct or wrong. Nobody has written the code. Hello? Yes or no? Anyone has written the code? Or at least try to write the code, some statements, some instructions, because already we have taken 4 to 5 programs on the timer, but that to be of mode 1. Only here the mode is changed. Yes, Rohit Nakashe. Hello? Rohit, are you there?
Yes, ma'am.
Huh. So what is the status? Have you written the code? Switch on your camera. Hello?
Yes, ma'am. Just a second.
So what about others? Praniti, are you there? Hello?
Yes, ma'am.
So have you tried the code?
No, ma'am, I forgot.
How you forgot? So I will give the 2 minutes because it requires hardly 1 to 2 minutes. Program structure remains the same. Already I told the steps. Load the tmod, load th, because here it is a 8-bit timer. So value is to be loaded as 5. Value to be loaded in timer register is just 5. Then which port is required? So P1.0 port is there. Just according to your understanding, make it on and off. Then the start timer, then poll the timer overflow flag, clear timer overflow flag, clear timer. That's it. So try to write the code. I will give just 2 minutes. So everyone should write the code on their own. I will ask randomly to any one of the student.
मॅम ऑन टाइम आणि ऑफ टाइम किती घ्यायचा आहे ड्युटी
ऑन
साठी?
टाइम ऑफ टाइम नाही दिलेले, स्क्वेअर वेव म्हटलंय. म्हणजेच काय,
या कळालं.
मेन्शन केलेलं नाहीये. म्हणजे 50% ड्युटी सायकल, म्हणजे वेगवेगळं करत बसायची. आणि इथे तुम्हाला कॅल्क्युलेशन करायचीच नाहीयेत सुयश. हा कोड पहिला टायमर मोड 2 चा आहे, त्याच्यामुळे मी काय दिलीये तुम्हाला, डायरेक्टली व्हॅल्यू दिलीये. 5 व्हॅल्यू काय दिलीये, टायमर मध्ये लोड करायची व्हॅल्यू दिलीये. जसं आपण टायमर मोड 1 चा पहिला प्रोग्राम घेतला होता, FFF2 ही व्हॅल्यू मी डायरेक्टली तुम्हाला दिली होती. आणि नंतर आपण कॅल्क्युलेशन केले. प्रॉब्लेम स्टेटमेंट व्यवस्थित वाचा. असं काही दिलेलं नाहीये की 5 मिली सेकंड 10 मिली सेकंद. म्हणून मी आता मेन्शन केलं की टायमर रजिस्टर इथे TH मध्ये व्हॅल्यू लोड करायची आहे. इथं TH मध्ये फक्त व्हॅल्यू लोड करायची आहे, कारण हा ऑटो रिलोड आहे. डायग्राम शेअर करते, चेक करा. डायग्राम चेक करा. डायग्राम मध्ये काय दिलंय, मोड 2 मध्ये हा 8 बिट टायमर आहे. 8 बिट टायमर मुळे त्याची मॅक्सिमम व्हॅल्यू जाते FF 256. का, कारण TH मध्ये व्हॅल्यू आपण टाकायची, ते ऑटोमॅटिकली TL मध्ये रिलोड होत जाते. म्हणजे मला दोन्ही रजिस्टर मध्ये टाकायची गरज आहे का मोड 2 मध्ये? नाही, कारण मोड 2 मध्ये तो 8 बिट म्हणूनच वापरणार आहे. 8 बिट म्हणजे एनीवन, TH or TL. पण अकॉर्डिंग टू द हार्डवेअर डायग्राम, you have to load in TH, it will have reloaded or it will be loaded in TL. So that is the beauty of this mode 2, timer 1 and mode 2. So that's why I have again shown, I have discussed this diagram previously, but we are writing the code for timer and mode 2. That's why again I am repeating this diagram. Okay, so according to that, just write the code and do it fast. It requires hardly 1 minute. Praniti, right now you can write the complete code. Rohit. Rohit.
Yes,
Rohit
ma'am.
Nakashe, show it. Show me your code now.
Just a second.
Don't waste the time. What happened, Rohit? You are wasting the time. Hello?
Now I'm putting the value on TH0 and this one.
Show it to
50,
me.
50%, right?
So show me your notebook first. Make your camera on. So what you have written? Read the instructions. What will be the first instruction? Keep your camera on. Unmute yourself.
Move P mod
Huh?
has 20H.
Why 20?
Timer 1, mode 2.
Okay. You know the logic, na?
Yes.
Okay. Then
Move TH0.
why 0? Right now you told ki timer 1. So TH0 is for
No, no, no.
what?
Yes, yes. For timer 0.
So what should be the here? Which value?
Move TH1.
Hash 5. Because I
5.
have given the value.
Yes, ma'am.
Okay. Okay. Then
Move P1. Port 1 because
what should we move to the P1 then? I have given P1.0.
yes,
So see, do it seriously, and if you are not getting anything, you should ask me the questions. You should ask me your doubts.
yes,
So
ma'am.
don't take it lightly. For all the students I am telling, not to only the Rohit. So if nobody is asking the question, nobody is taking the lecture seriously. We will not repeat these things afterwards, because we are wasting our time. So why should we repeat the all complete lectures? So you should take it seriously. Whatever the doubt you have, if you are not getting anything, you just ask me to repeat the things in the next lecture. But that in that case, you should study the things already covered. Then I will repeat 100 number of times. Already I told. If you are not getting any concept, I will repeat that concept. I will teach that concept 100 number of times. But you should get the logic. That is the thing. And in the practical as well as in the theory exam, you should do well. That is the main intention, nothing else. Okay. So see, you can switch off your camera, Rohit, now. So already we have discussed ki this is a timer and mode 2. So already I have given the diagram. Already I have discussed the diagram. So just concentrate on the diagram. Is all the time when the timer mode 2 is asked, the very first thing is you should remember ki timer, any timer 0 or 1 in mode 2, it is acting as a 8-bit timer, and the auto reload facility is available. Okay, now, so what do you mean by 8-bit timer? So what you understand from 8-bit timer? So here in mode 2, timer can count up to only ff value, and that's why the maximum count is ff, because 8-bit 2 to the power of 8 is ff. So that you should remember. So each and everything related to the hardware diagram that is used for writing the programming. So that's why, so see, now I will just write the program one by one steps. Just concentrate on the screen. So as per the discussion, very first instruction is move p mod comma hash 20h. So why it is so, that is already discussed. I am using the timer 1 and mode 2. That's why the value comes to 0. T mode register value, you can cross check. Then move TH1, always TH1 or TH0 depending upon timer 0 and timer 1. So right now I am using the timer 1, that's why it is TH1. Okay, and already I have given the value as 5, so directly you can load the 5. If it is asked 10 millisecond, 5 millisecond, you have to calculate by the same procedure and put the value. But right now I have provided the value as 5. So directly I will put in always for mode 2, the value should be loaded in TH register according to the diagram status. load in TH, it will go in TL. Okay, so this is the thing. Then next is I want to make, or I want the square wave at P1.0 pin. Okay, it is mentioned in the problem statement. So I will use the instruction CPL P1.0. You can use the move instruction also, but basically move instruction is used for the complete port P1. Port P1, if I want to move FF value or 00 value, already we have done in the previous program. That is also correct. But right now we are concentrating on a single pin. That's why this is a bit manipulation instruction. Works on a single bit. That's why I'm using the CPL instruction. That is the complement instruction. It does the same job as that of your move instruction, moving FF and moving 00 also. But as I'm using a single pin P1.0, I'm using the instruction complement, that is CPL instruction. So the T mod is loaded, TH is loaded. I want P1.0, the square wave should be generated. So use the instruction CPL P1.0. Then I will start the timer. So as to start the timer, set B PR1. Isn't it? Then next, what is the very simple program is there, and already we have taken 4 to 5 programs based on the timer. Here only that mode is changed. Now see, if you just compare the previous program with this program, basic structure remains same. Just concentrate. Then we write the instruction JNB. So JNB, which flag I am polling or checking, PF1 as the timer 1, and then I will use the label as back. Yes. So then the label is again the back. Yes. Next instruction is I have to stop the timer. Yes. So basically here no need to write the stop timer, because the if you don't stop, then automatically the value is loaded and there is no need of sjump instruction, because the value is loaded automatically. I can directly write CLR PF1. That's it. Now see, whatever the code that you have to write in the key and check this performance afterwards. Okay. So what I have done is, so how it works, first of all, timer is declared, initialized, the value is loaded. Initially P1.0 is 0, the timer is started, it will start counting from 5, 5, 6, 7, 8, 9, 10, likewise A, B, C, D up to FF. Once it becomes FF, it becomes 00. This flag is raised. It will come to the next instruction, CLR TF1. This TF1 flag is cleared for the next iteration, and no need to stop the timer. You can stop the timer also, because I have used the instruction sjump back. So see, purposely I have missed one instruction. You just run this code on key and make the changes according to the output status, or whether this is sufficient, that you have to tell me in the next lecture. Okay. And sjump back again I have written, because it will go to that instruction itself. So why it is so? हे sjump back मी असंच लिहिलंय, वरती सेट बी ला पण नाही लिहिलंय, हे कोणी सांगू शकेल? sjump back, the back is here. Again I have used the same label, but I have not used here or in the second instruction, or at least at the fourth instruction.
ऑटो रिलोड होतं ना, तर मग ते वरून परत
ऑटो रिलोड होतं ना, मग त्याच्यामुळे परत मला व्हॅल्यू लोड करायची गरज आहे का? नाही. मी टायमरला स्टॉप नाही केले, त्याच्यामुळे मला परत टायमरला स्टॉप करायची गरज, स्टार्ट करायची गरज आहे का? नाही गरज आहे म्हणून. ठीक आहे. So purposely I have missed one thing. Just check it on key and tell me what happens related to this program. Okay. So in this way, for timer 2 programming, you have to write the code likewise. And the thing is, always very different thing with respect to mode 1 is always load the value, whatever is the value in mode 2 in TH1 register. That's it. That is the important thing. Whereas in timer mode 1, already we have loaded in TL and TH register, and all the time we have to reload. Here in mode 2, it gets automatically reloaded. Okay. Now, just take one program that is related to the mode 1 again. But the thing is, how to repeat the, first of all, we will see before this program, by each and every mode, what will be the maximum delay generated. Now, just see. Suppose I take mode 1, it is 13-bit now, yes or no? Mode 1, 13-bit timer, yes? Then
16-bit.
mode 0, 13-bit, and mode 1, 16-bit, mode 2, 8-bit. So I will just highlight the all modes parameters, and then we will see ki, in each mode how much is the delay generated by that mode. That is very, very important. So why it is required? Suppose, for example, in the exam, it is asked to calculate the delay of XYZ amount or X amount. You should know which timer and which mode I should select, and how you come to know which mode I have to select. But right now we are not concentrating on that part. But if it is asked ki, you have to generate a 10 millisecond of delay, so which timer mode is sufficient right now? Can you just understand ki which mode is sufficient? No, randomly you can take. But if you calculate what is the maximum delay generated by each timer in a timer in each mode, then you can easily select according to the problem statement, according to the delay generation value, which mode is suitable for that delay generation. Okay, are you getting what I am telling? How you have calculated how much delay generated by any value? We have seen FFF2. So what is the formula for that? Is FFF2 minus maximum value minus FFF2 into 1.085 microsecond, isn't it? Now just tell me, when the maximum delay will be generated from the timer in any mode? What is your understanding? Timer ni maximum delay kadi generate hoil?
When it will start from 0.
एक्झॅक्टली. कारण मी जेव्हा 0 पासून स्टार्ट करेल आणि तो मॅक्सिमम पर्यंत जाईल, तीच त्याची मॅक्सिमम रेंज आहे ना, मग तेव्हाच तो डिले जनरेट मॅक्सिमम करेल. ओके, सो अकॉर्डिंग टू दॅट कॅन आय कॅल्क्युलेट द मॅक्सिमम डिले जनरेटेड इन ईच मोड नाव? आता प्रत्येक मोडनी मॅक्सिमम डिले जनरेट कधी होणार आहे हे काढता येईल मला. काय करायला लागेल? सपोज मोड 0 घेतला मी, ठीक आहे, मोड 0 घेतला, तर आता आपण काय करतो, जी काही इनिशियल व्हॅल्यू आहे ती मॅक्सिमम व्हॅल्यू मधनं मायनस करतो, बरोबर. 65536 मायनस FFF2 किंवा त्याचं डेसिमल व्हॅल्यू. आता मोड 0 मध्ये टायमर किती बिट्सचा आहे? 13 बिट्सचा आहे. 2 to the power of 13 म्हणजे किती येतं? 1FFF, आणि त्याची डेसिमल व्हॅल्यू येते 8192. तुम्ही कॅल्क्युलेशन करू शकता. ही टायमर ची मोड 0 मधली मॅक्सिमम व्हॅल्यू आहे. त्या मॅक्सिमम व्हॅल्यू मधनं आपण काय व्हॅल्यू सबस्ट्रॅक्ट करतो? टायमर मध्ये इनिशियल व्हॅल्यू जी काही लोड केली आहे. आपण आत्ताच सुयशनी सांगितलं की मॅक्सिमम डिले जनरेट कधी होणार आहे? व्हेन द मॅक्सिमम डिले गेट्स जनरेटेड बाय एनी मोड when the initial value loaded is 0, then it will get count its maximum count value for that mode. So the initial value is 0. Okay, so this is the count into 1.085 microsecond. So do the calculations. Do the calculations and tell me the value. This is microsecond, huh? Yes, do the calculations. Means what you have to do here is 8192 into 1.085 microsecond. So first of all multiply and tell me in the seconds. Yes, all of you have to do the calculations. Don't wait for the answer. Praniti, tell me the answer. 8192 into 1.085 microsecond.
8847.36 ms.
Ms means what? In millisecond, how you can write? 8.8 millisecond.
Yes, ma'am.
8.8 millisecond. Yes, correct.
Yes,
So I
ma'am.
will just write. Yes. Means what is the meaning of this 8.8 millisecond? In any timer, timer 0 or timer 1, if you select the mode 0, the maximum delay generated by mode 0 is just 8.8 millisecond. Are you getting the meaning of this statement? Everyone. Suppose I want to generate a delay of 15 millisecond, whether the mode 0 is suitable?
No, ma'am.
No. So according to that, in the exam, you should be select the proper mode for the timer calculation. That's why I'm doing this. And no need to mug up this value 8.8 millisecond. On the spot also you can calculate key in mode 0 what should be the maximum delay generated, in mode 1 what should be the maximum delay generated. You can easily calculate. You just remember the logic how to calculate the maximum delay. So the mode will give the maximum delay when it will start from the minimum value. And what is the minimum value? 0 value. So that's why that 0 value is subtracted from the maximum value. So obviously I will get the maximum steps, number of steps into 1.085 microsecond. Okay. So in the same manner, we will do for mode 1. Okay. So in mode 1, what value I should take? 16 bit means इथे मी चेंज करायचं राहिलंय. ओरली सांगितलं.
65536.
65536. कसं आलं हे कॅल्क्युलेशन्स करा. तुम्हाला पण माहिती पाहिजे. 2 to the power of 16. म्हणून 65536 किंवा FFFF. ओके, याच्यात झालं का ते? Yes, 65536 minus 0. हे पर्पजली मी 0 लिहितीये. मॅडम 65536 minus 0 म्हणजे 65536च ना. मग कशाला लिहिताय? पण आपल्याला ते कळलं पाहिजे. तो स्टँडर्ड फॉर्म्युला आहे की when the maximum delay will get generated when the timer mode will start from the minimum value, and the minimum value is 0. That's why I'm taking this. Okay, into 1.085 microsecond.
7.21 millisecond.
7.21. No, it should be greater than mode 0, na? Just check it once. Because in mode 0, I am getting 8.8 millisecond. So how should I get
71.106.
Exactly. 71.11 millisecond. Yes, everyone is getting. Check the calculation once. Check the calculations. Means in mode 1 up to 71 millisecond I can generate a delay. Yes. So just check the calculations. Then last mode 2. So in mode 2 the maximum value is 256, that is FF, because in mode 2 timer works as a 8-bit timer. Okay, so minus 0, again the same thing. Just do the calculations. 1.085 microsecond. So tell me the answer.
Ma'am, 0.27 milliseconds.
Yes, correct. 0.277 millisecond. So see, in mode 2, very small delay. But what is the facility, or what is the beauty of the mode 2? Auto reload facility is available. Okay. So are you getting this concept? Whatever we have calculated right now, we have calculated the maximum delay generation in 3 different modes, that is mode 0, mode 1 and mode 2. And when user will get the maximum delay generation by that mode is when the timer will start from the minimum value. And obviously the minimum value is 0, so that's why we have taken the 0 value and subtracted from the maximum count. So I will get the maximum count only. Okay, and that is to be multiplied with the step size 1.085 microsecond. That is the pulse size. We have calculated the value from the 11.0592 megahertz. In some of the both, this value may change if the already I have discussed, if the frequency is 12 megahertz and if the frequency is 22 megahertz. According to that, you have to just do the calculations. But the standard frequency is 11.0592 megahertz. But you have to read the problem statement carefully. According to that, you just make the changes. Don't mug up the values. You have to calculate. If any value is not remembering, then you have to calculate the value at that instant. It means what is the thing? You should remember the logic. That's it. Okay. Now, just tell me, I have to generate a delay of 5 seconds. Concentrate on the statement. I have to generate a delay of 5 seconds, obviously by timer 1, whether it is possible. Are you getting statement? I have to generate a delay of 5 seconds
Not possible.
using timer 1, whether it is possible.
No.
Why? Any other logic can you use? Can I use any other logic? Then what is the use of timer then? Only for generation of millisecond delay. Are you getting the statement? Or are you getting the problem? If I could not generate a delay of 5 seconds, what is the use of then timer? There should be some logic, na? And that's why I have first of all calculated the maximum delay generated by the timer, and then I have asked this question whether the 5-second delay can be generated by timer. So the task is I require a 5 seconds of delay. Okay. So just rearrange this 5-second value in terms of millisecond. So 5 seconds means 5000 millisecond. Yes or no? Yes?
Yes.
5 seconds is 5000 millisecond, correct? So can I write this 5 seconds as 50 into 100 millisecond? Can I write likewise? Hello? Yes, can I write likewise? 50 into 100, that is 5000 millisecond. I am just rearranging the 5000 value. And whether this 50 value can be generated, 50 millisecond can be generated. 50 millisecond into 100 millisecond. So 50 millisecond is generated by timer 1 in mode 1. हॅलो,
येस मॅम.
बरोबर आहे का? जे स्क्रीनवर दिसतंय ते आता काही लक्षात येतंय कसं करता येईल? नाही लक्षात येतंय? येस, मी काय केलं, 5 सेकंड डिले मला जनरेट करायचा आहे. पण तुम्ही आता बघितलं की प्रत्येक मोडनी मिली सेकंड मध्येच डिले जनरेट होतोय. मग 5 मिली सेकंडला मी काय केलं, 5000 मिली सेकंड, 5 सेकंडला मी 5000 मिली सेकंड केलं. 5000 मिली सेकंड, 5000 ला मी 50 इंटू 100 मिली सेकंड केलं. म्हणजेच काय, 50 मिली सेकंड इंटू 100 मिली सेकंड ना, म्हणजे 5000 मिली सेकंड. ठीक आहे. मग टायमर 1 नी मी 50 मिली सेकंडचा डिले जनरेट करू शकते का?
येस.
टायमर 1, मोड 1 आणि टायमर 1 नी मी 50 मिली सेकंडचा डिले जनरेट करू शकते. त्याला मी 100 टाइम्स रिपीट करू शकते.
येस मॅम.
100 टाइम्स रन करायचं त्याला. मग कितीचा डिले जनरेट होईल? 5 सेकंडचा. कारण जर त्या टायमरनी मला 5 सेकंडचा डिले जनरेट करताच येत नसेल तर यूज काय त्याचा? Actually, this problem occurs only in 8051 microcontroller because advanced features related to timer is not available in 8051. In peak microcontroller, in ARM microcontroller, there is a concept of pre-scaling and post-scaling. So with the help of that, you can generate any amount of delay. So that is not available in 8051 microcontroller. That's why we have to do this manual process. Are you getting? So I will generate the 50 millisecond delay and that is to be repeated 100 times. So 50 into 100, that is 5 second delay or 5000 millisecond delay you can generate. Okay. So first of all, now calculate the value for 50 millisecond. So do it fast. 50 millisecond साठी काय व्हॅल्यू असेल ती काढा, कॅल्क्युलेट करा. 50 मिलीसेकंद टायमर 1 आणि मोड 1. मोड 1 म्हणजे 65536. पण 50 मिलीसेकंदचे व्हॅल्यू काढताना काय प्रोसेस करायची आहे? 50 मिलीसेकंद डिवायडेड बाय 1.085 मायक्रोसेकंद and that is to be subtracted from 65536. आपण ऑलरेडी हे कॅल्क्युलेशन्स केलेले आहेत, चेक करा.
फोर बी एफ डी.
नाही, एकदा चेक कर व्यवस्थित. 4C00 येते. जर बाकीच्यांचं पण ते चाललं तर आपण घेऊया, ते काही प्रॉब्लेम नाही. कॅल्क्युलेशन माझ्याकडे
मैम
व्हॅल्यू नाहीये.
4BFE आ रहा है, 4BFE.
4BFE एकदा चेक करा परत. कारण बुक मध्ये 4C00 लिहिलं होतं. ठीक आहे, त्याने आपल्याला खूप काही फरक नाही पडणार, आपल्याला लॉजिक समजून घ्यायचंय. 4BFE ना, मग FE कुठं जाईल? TL1 मध्ये, आणि 4B कुठे येईल? ठीक आहे, हे ऑप्शनल आहे. स्टार्ट टायमर JNB. आता हा बेसिक प्रोग्राम झाला 50 मिली सेकंड साठी, तो परत एक्सप्लेन करायची गरज नाही असं मला वाटतंय. टायमर टी मोडला लोड केलं 01 नी, 01च येते का व्हॅल्यू? टायमर 1 आणि मोड 1 का 10 येते? काय येणार? टायमर 1 आणि मोड 1 म्हणतोय ना आपण. काय येणार मग? 10 येईल ना. टायमर 1 आणि मोड 1 10
येस
येईल ना.
मॅम.
हा, 10H. आता तुम्ही व्हॅल्यू कॅल्क्युलेट केली आहे 50 मिली सेकंड साठी. 4B काय व्हॅल्यू कॅल्क्युलेट केली आहे? 4BFE, बरोबर. आता ह्याच्यातला हा लोअर बाईट FE आणि हा हायर बाईट. मग आता 4FE मी TL1 मध्ये लोड केला, 4B मी TH1 मध्ये लोड केला. ओके, आता हा मोड 1 आहे, त्याच्यामुळे ऑटो रिलोड फॅसिलिटी नाहीये, तर दोन्ही मध्ये लोड केलं. CPL P1.5 हे ऑप्शनल आहे, जो स्टेटमेंट मध्ये दिलं असेल किंवा बेसिक स्ट्रक्चर प्रोग्राम लिहिला तरी चालणार आहे. त्याच्यानंतर टायमरला मी स्टार्ट केलं, तर टायमर कुठला आहे माझा? 1 आहे, त्याच्यामुळे मी TR1 म्हणते. त्याच्यानंतर टायमरला स्टार्ट केल्यावर काय करायचंय? TF1 फ्लॅग पोल करत राहायचंय. ठीक आहे, त्याच्यानंतर TR1 ला स्टॉप करायचं आणि TF1 ला पण स्टॉप म्हणजे क्लिअर करायचं. ठीक आहे, आता काय होईल? याने काय होईल? एक 50 मिली सेकंडचा जनरेशनचा डिले जनरेट होईल, कारण हा एकदा रन होतोय. आपल्याला त्याला काय करायचंय? 100 टाइम्स रिपीट करायचंय. 50 into 100 म्हणजे 5000 मिली सेकंड म्हणजे 5 सेकंड. मग काय करावं लागेल रिपीट करायचं म्हणजे? लॉजिक सांगता येईल? मनाली मी 10 काय लिहिलंय मनाली? ओके, 10 का टायमरचं. ठीक आहे, लॉजिक सांगता येईल का तुम्हाला? सगळं तुमच्या समोर आहे. 50 मिली सेकंडचा डिले जनरेशन साठी कोड लिहिलाय, त्याला 100 टाइम्स रिपीट करायचंय. म्हणजे काय करायला लागेल? मग आता 100 टाइम रिपीट करण्यासाठी काय लॉजिक लावावं लागेल याच्यात? येस, विचार करा जरा. काउंटर घेता येईल? एक काउंट घेऊ शकतो ना आपण रजिस्टर मध्ये, आणि त्याला काय करायला लागेल?
डिक्रीमेंट.
एक्झॅक्टली, हेच तर लॉजिक आहे. आता 100 टाइम्स आहे, मग मी लॉजिक प्रोग्राम मध्ये कसं त्याला अप्लाय करणार आहे? हाऊ आय अप्लाय दिस लॉजिक इन द इन्स्ट्रक्शन और इन द प्रोग्राम? ऑब्वियसली आय हॅव टू टेक वन काउंटर. काउंटर म्हणजे काय? वन व्हॅल्यू आय हॅव टू टेक इन द रजिस्टर. ओके, आणि शेवटी त्याला काय करत जायला लागणार आहे? डिक्रीमेंट. मग डिक्रीमेंट साठी 8051 मध्ये कुठली इन्स्ट्रक्शन आहे? DJNZ, आणि मग त्याला आपण रिस्ट्रिक्ट करू शकतो. ठीक आहे, चेक करा. आता तो काउंटर इनिशियलायझेशन असेल, त्याच्यामुळे मला तो स्टार्टला करायला लागेल. मूव, कॅप्स लॉक ऑन करते, मूव R3, हॅश 64H. आता बघा 64H का घेतलं ते सांगा मला. आता ही एक इटरेशन झाल्यानंतर तो परत रिपीट व्हायला पाहिजे ना. असं कुठपर्यंत रिपीट व्हायला पाहिजे? आपण आता आत्ताच्या केसमध्ये कंटिन्युअस रिपीट व्हायला पाहिजे सांगितलं, पण आता आपला काउंट घेतलाय म्हणजे तो रिस्ट्रिक्ट होणार. 100 टाइम्स रिपीट होणार आहे आणि मग 5 सेकंडचा डिले जनरेट होईल. मग हे झाल्यानंतर DJNZ कशाला डिक्रीमेंट करायचंय? R3 ला. तुम्ही इथं R0 to R1 कुठला? R0 to R7 कुठलाही रजिस्टर देऊ शकता, R3 आणि रिपीट. रिपीट मुद्दामून मी वर्ड लेबल दिलाय, हा लेबल तुम्ही दुसरा पण लेबल देऊ शकता. आता ह्या रिपीटचं कुठं लोकेशन असलं पाहिजे ते सांगा. रिपीट लेबल मी कुठे देणार? रिपीट लेबल कुठे द्यायला पाहिजे? इयरच्या इथेच द्यायला लागेल ना? येस और नो? का तर ह्या व्हॅल्यू परत लोड करायला लागतील, परत टायमर स्टार्ट होईल, परत तो असं 100 टाइम्स होईल. ओके. आणि जेव्हा R3 0 होईल, 64 म्हणजे 100 आहे, त्याची हेक्सा व्हॅल्यू घेतली आपण, जेव्हा तो 0 होईल तेव्हा तो बाहेर पडेल लूपच्या. ठीक आहे. असं इन दिस वे, if you want to generate any amount of delay by this logic, you can generate the delay. So for that purpose, you should know the maximum delay generation by each mode. That is very, very important. Then you can just get a logic for the same and repeat the timer for that much number of time. हे सगळ्यात इम्पॉर्टंट आहे. Yes. So try this code on the Keel Microvision also. Why I am telling this is, if you try whatever the code, timer code you have written, then you can able to make the changes in the code according to your understanding, and the concepts or the ideas related to the timer will get clear. That is important thing. Okay. Now tell me any doubts if you are having, because for timer we are done with the timer. You just try the number of code, ask me if you are having any doubt, and this is very, very interesting, important and simple topic. Don't think it is very difficult. The number of calculations are there. Do the practice, try to write the code on your own, then you will find it as a simple one. Okay. So for timer, we have started with the timer modes, then the registers, T-mode register, T-con register, and then the TH and TL register, their organization, the theory part. Then we have seen the hardware diagram. So how the timer frequency is divided by 12, then the gate bit, then INT bit, then TR bit, then the timer different modes, so TL and TH, and how it operates in the different mode, what is the size of the timer in different mode. This all theoretical part we have completed. Then we have started with the programming. Before starting the programming, we have seen the algorithm for the same, that is steps to write the program. That steps are very, very important. Again I will repeat, in any type of timer programming these steps are same. Very first thing is, you should require the T-mod register, calculate the value of T-mod register, then calculate the value TH and TL register, initial value according to the delay generation. Right now we have calculated for 50 millisecond. Load that value in the respective register. Then start the timer. Then pull the TF flag, that is timer overflow flag. And lastly, stop the timer and clear the timer overflow flag. So why to clear the timer overflow flag? For next iteration. If you want continuous square wave, you can use the sjump instruction. Otherwise, directly you can end the code. Okay, that is up to you. That is up to the problem statement. Somewhat minor changes user has to do according to the problem statement. That's it. So that's it from my side for the timer. So we have taken the number of programs, the calculations, two types of calculations we have seen in the timer. One calculation is, if the initial value loaded in the timer is already given, how much delay is generated from that value, the procedure to calculate the same. And next thing is, if I want some delay generation, that is the X amount of delay, 5 millisecond, 10 millisecond, so as to generate that delay, how much value is to be loaded in the timer register. These two important calculations we have seen. Don't mug up the calculation. Try to understand the logic. so that you can calculate that value at any instant. Okay, so this is related to the timer. In the next lecture we will start the serial communication. By that time, just practice the programs on keel of all the programs we have taken on the keel. And if you are finding any problem, you can ask me the doubts on the WhatsApp. Already I told, if you are finding any doubt on the keel, just make a screenshot and send it to the WhatsApp number. Then I will get the idea what type of problem you are facing while doing the program practicals, and then I will give you the solution for the same. Okay, so should we stop here today? So today you have one lecture only, and after that you have to join at 12:10 for the practical. If you are having any doubt, you can ask me. If you are not getting anything, you can ask me. And by that time, if you have any doubt, just think on it and give the attendance. So today is 23, na?
Hello, ma'am.
23 or
24.
24?
24.
24, na? Yes, give the attendance.
Hello.
हाँ, यतीश, बोल.
हाँ मॅम मॅम मला पीपीटी पाहिजे होते या टायमरचे.
हाँ ठीक आहे, मेलला सेंड करते मी. आय थिंक सेंड केलं एकदा चेक करते. टायमरच्या नाही, एकच पीपीटी आहे, त्याच्यातच सगळं आहे. नसेल तर सेंड करते मला
सगळं
एकदा.
आहे घरी तुम्ही सांगितलेलं.
हा, हॅलो,
तुम्ही सांगितलं ते सगळे का ते हार्डवेअर डायग्राम वगैरे त्याच्यात?
हा, ही जी पीपीटी आहे ना, ही ब्ल्यू कलरची, डे 1 पासून
हा, हीच
एकच
पाहिजे
पीपीटी
मला.
वापरते. डे 1 पासून एकच वापरते. फीचर्स पासून याच्यात ते सगळं म्हणजे
हा मी शोधली मॅम,
कम्प्युटर.
नाही भेटली ती, त्याच्यावर नव्हती
ठीक आहे,
वाटतं.
सेंड करते तुमच्या गुगल ग्रुपवर.
परत
ठीक
एकदा
आहे,
सेंड करून.
ठीक आहे, ठीक आहे. हे करा, अटेंडन्स द्या. मी एकदाच नंबर घेणार आहे, त्याच्यामुळे बी अटेंटिव्ह. रोल नंबर 1,
Present, ma'am.
रोल नंबर 2,
Ma'am.
रोल नंबर 3,
Present, ma'am.
4,
Present, ma'am.
5,
Present.
6,
Present.
7,
Present, ma'am.
8.
Present.
एक मिनिट. 9, रोल नंबर 9, 10.
Present. Present.
कोण प्रेझेंट आहे? 10 का 9?
दोघं प्रेझेंट आहेत.
9 ची नाही लागणार आता आज अटेंडन्स. रोल नंबर 11,
प्रेझेंट मॅम.
12, 12,
Present, ma'am.
13,
Present, ma'am.
14, 15,
मॅम.
17,
Present, ma'am.
18,
Present, ma'am.
19,
Present, ma'am.
20,
Present, ma'am.
21,
Present, ma'am.
22,
Present, ma'am.
24,
Present, ma'am.
25,
Present, ma'am.
26,
Present, ma'am.
27,
Present, ma'am.
28,
Present, ma'am.
29,
Present, ma'am.
30.
प्रेझेंट.
आकाश महाजन कोण आहे? जरा व्हिडिओ ऑन कर. हॅलो,
हा
अब्सेंटी आहे तुझी डिफॉल्टर मध्ये बहुतेक. तू डिफॉल्टर लिस्ट सेंड करते मी नंतर, त्याच्यामुळे तुमची अटेंडन्स व्यवस्थित द्या. इथून पुढे तुम्हाला रूल सांगितलेले आहेत. प्रत्येक जण ओरली अटेंडन्स घेणार आहे आणि तुमचं रिझन सांगा जे काही असेल ते. आकाश महाजन होतंय का कॅमेरा ऑन? 31,
Present, ma'am.
32,
Present, ma'am.
33, 34, 35,
Present, ma'am.
Present, ma'am.
36, 37,
Present, ma'am.
38,
Present, ma'am.
39,
Present, ma'am.
40,
Present, ma'am.
41, 42,
Present, ma'am. Present, ma'am.
43, 43, 44,
Present, ma'am.
45,
Present, ma'am.
46,
Present, ma'am.
47, 47, 48,
Present, ma'am.
48 na?
Huh.
49,
Present, ma'am.
50, 50, 51,
Present, ma'am.
52, 52, 53,
Present, ma'am.
54, नहीं है 55,
Present, ma'am.
56,
Present, ma'am.
57,
Present, ma'am.
58,
Present, ma'am.
59,
Present, ma'am.
60,
Present, ma'am.
60, 60,
Present, ma'am.
62, 63,
Present, ma'am.
64,
Present, ma'am.
65, 65, 66,
Present, ma'am. Present,
60,
ma'am.
67, 67,
Present, ma'am.
68,
Present, ma'am.
69,
Present, ma'am.
70,
Present, ma'am.
71, 72,
Present, ma'am.
72,
Present.
okay, 73, 74,
Present, ma'am.
Jaipur,
Present, ma'am.
75, Mrunal Jadhav, Neeraj Mistry, 76,
Present, ma'am.
77,
ma'am.
78.
Present, ma'am.
Okay, thank you all. If you are not having any doubts, you can leave the meet.
Thank you, ma'am.
Join at 12:10 for the practical.